Probably the most common question that I get whenever I'm teaching is how on earth can you solve all of these difficult problems, particularly exam questions? Now, I try to be funny on my students in saying that I've done all of the papers all the way back to 2010, which is kind of real. So there's the benefit of hindsight, but even older papers, I'd be surprised about how many problems I can actually solve in the old course. And there's six kind of different strategies that people use. So here are the different six. Now, technically, 5 and 6 aren't strategies, but I will touch on them because they are very important. Because psychology plays a big factor um, in doing mathematics problems, or really the exams in general. So I'm going to break them down in the order that I have them. So the main way that I do things is by using the Gus method. Now, that's not because I watch Breaking Bad. In fact, I haven't even watched it at all. But Gus here stands for the three different stages when solving a maths problem, particularly if it involves a formula. So this is the one I also do to my physics people as well. I always recommend doing Gus for physics problems. So just in kind of an example, let's just say we were doing the sine. Or not the sine, but pretty much just and trigonometry E. So let's say we just have a sample triangle here. We're given this angle here is 25 degrees. We're given this length as 20 meters. And we're asked to find out what this distance x here is. So pretty standard junior cert trigonometry problem. I'm not going to go through the exact answer or anything, just how I do things with the Gus method. So the G in the Gus stands for our givens. So what information is the question actually telling us? Now, by givens, I mean questions or bits of information that are relevant to the question. So I've seen this a bunch of times before, but I've seen people write down that Alice was looking out at a boat or something, for example, and there was no one else in the problem. So writing down the person's name doesn't help us get us really any closer to the answer. It could as easily be Bob or Charlie or Derek looking out, and it wouldn't change the final result. So anything numerical, note. So here we are given, say, the horizontal distance as 20 meters. We're also given an angle of 25 degrees. And in particular, the horizontal is, because it has the right angle and the marked angle, that is the adjacent side. And that's our given. You could write down that we have a right angle triangle, so that could lead you towards your SOHCAHTOA knowledge and general trigonometry knowledge. The U is the opposite of our givens. That's our unknowns. That's the value that we're trying to find. So the unknown in this case is that vertical distance, which is x meters. And because it's directly opposite to the 25, it is therefore, by definition, the opposite side. So finally, S stands for our solution. So what we have to do is find a formula, either think of one or find one in the log tables, which links our givens and our unknowns in a nice formula. So in the case of this, because we have an opposite and an adjacent, the hypotenuse doesn't matter. So for junior cert knowledge, we note that that's going to be the tan of the angle. So tan of our angle is the opposite over the adjacent. And then from here, I'll just fill in the basic information. So we have tan of 25 degrees is the opposite x over the adjacent 20. And then from there, you can easily find out what x is. So that's the Gus method, givens, unknowns, and solutions. And it works well for any question that involves usually one or two formulas. But what happens if it doesn't? What happens if it's a little bit harder to discern? That's where the second method comes in which I call the breakdown. Now, that doesn't mean to start crying all over the maths paper. The breakdown method, I tend to have a particular example. I think it was possibly one of the 2012 papers or something, where you had a cylinder. Inside the cylinder, there was a tetrahedron. So, cylinder, tetrahedron. The cylinder had some particular dimensions that I don't really remember, and so did the tetrahedron. And you need to find out what the maximum volume the tetrahedron can have inside of the cylinder. Now, what's going on there? Wrong button. I vaguely remember this question, and it was kind of on its own. So there wasn't atom built up to it. It was just a question in isolation. So what I tell the students is, okay, well, you're going to need the volume of the tetrahedron because we want to find the maximum of it. So we look for the volume of the tetrahedron first, whatever that is. Then the volume of the cylinder, because we'll need that as well. So volume of the cylinder, whatever that happened to be. But then we also need to notice that it involved the word maximum. And usually when we have maximum or minimum, we want to be able to differentiate. I think the variable was A. So we need some differentiation knowledge as well as the two volumes. And with that, you pretty much just have all the setup. So it's not necessarily a given because we weren't told to find the volume of the tetrahedron or cylinder. We're basically trying to find that ourselves through the logic of the question. And usually that's all that's really required. There's no other sort of complex formulas you might need. The volume of a tetrahedron you can easily find as a third base times the height. So if you can find the base of this triangle. And then using all the steps, you can get the question solved pretty nicely. So that's the breakdown method. Just breaking a larger problem into smaller sub-problems. Next is one that I really strongly recommend, and that's the idea of a sketch. Now, for anyone that has done inferential statistics, if they've watched this video, they will note that this is also quite important. So, in the ideas of probability, we want to find the probability of something happening relative to the area that the probability event, the event has underneath a particular curve that looks a bit like this. So if you were given that the event happening has a 5% chance of happening, the way that we would sketch this is here. And we'd put our particular Z score. So we would say that the probability of that happening is simply just the area here. So, which we will later do once we get to inferential statistics. This isn't actually too bad. But if it was a greater than, it'd be 1 minus that probability. But that's all for later us to think about. So statistics is quite handy. But as well, anything geometrical, especially to do with the circles, or the circle questions. So you might have, say, 2 externally tangent circles, and you want to find the tangents that hit both circles. So we're thinking, okay, there's one that goes a bit like this, and then there's one that goes like this. And you use either the Gus method or the breakdown method using your geometry knowledge in order to be able to find the equations of those two lines. So, uber important, I would think, for geometry questions. Another thing I would note is a lot of the exam paper diagrams are crap. So I always recommend drawing your own diagram because it helps you fill in sort of by your own heuristics. So by whatever style you want to do. So sketching out a question before doing any of the setup is another strategy I recommend. Vaguely the same is construction. So this is only really handy for geometrical questions. So what I mean by that is if you have, say, 2 different measurements, then construction would be, if I was just given that, we'd have a big angle here, say 2A, and then to make things a little bit easier, you might construct a line so that it completely bisects this angle, and you have 2 individual A angles there. So this is what we call drawing auxiliary lines. or as some other say, auxiliary. I've always just said this is auxiliary. So drawing any sort of auxiliary lines might help in particular questions. A way to note is that if you have a big angle, particularly in trigonometry questions, if it's 2 times some variable, you're probably going to have to bisect that angle somewhere. So that's the ideas of construction. Now, the other two, strategies 5 and 6, are mostly psychological. So I would think 6 is more important than 5, but I will still go through 5, and that's the idea of mathematical instinct. So if you've done a lot of questions, the one thing I would recommend is to trust your gut. Because you would have done enough problems to note that the SEC tend to use the same patterns pretty much over and over again. So trusting your gut is a very important thing to sort of have internally. So note that it's pretty much the same methods. So methods used similarly in all question styles. So you need to be able to trust your own algebra and also make assessments on the answer. And the kind of analogy that I use for this, well, not analogy, but kind of anecdote, that's the word. That's why I didn't become an English teacher, guys. The anecdote I tend to use for this is I was kind of sitting in a classroom back in 1949, but I was kind of sitting here doing my work. And then there was someone else next to me also doing their work. I think they were standing because they probably had a bunch of people kind of looking around them. They were a lot more popular than I was. But I got that the velocity of a golf ball in physics was about 15 meters per second, which is fine. That's not too sort of quick for a golf ball. But this other person over here, they were like, no, that's completely wrong. I asked them what their velocity was, and they got 15 million meters per second, which is a comparable fraction of the speed of light. So I was noting that, okay, 15 meters per second could be the answer to that particular question. I might have missed a bit of information or possibly a decimal point in my calculations, but I was reasonably happy with my 15 meters per second. But this other person with their 15 million meters per second, they still thought that this was the answer and didn't really end up doing too well in the final exam, as far as I was told. So I clearly noted that couldn't be the answer, so I completely discarded Anthony said, because the velocity of a golf ball can never be that fast. Another way in terms of more mathematical things instead of using physics is, say if I had a line and I was to split the line, say here. So I'd have a length here of x and a length here of y. If I got that the point was, say, a distance of 3x plus 3y along the x-axis, which would be somewhere over here, I would know that's completely wrong because it doesn't make sense in the picture. And it wouldn't also make sense in the problem to cut a line further along its boundaries. You know, that's like if you're trying to cut up a sandwich, that would be equivalent to saying, okay, go into the sitting room and start cutting off the door handle. That would get you your sandwich perfectly in half. So that's another thing. You need to build up instinct in noting what a correct answer is and what one should look like in the question. Now, the final one. I would think the most important of them all. And it's self-justification. I'm going to write down, I know I keep saying this, but I am now going to write down one of the most common things I hear whenever I start any Leaving Cert maths class, or especially when I'm tutoring. Or derivatives thereof. The whole perception of, I can't do maths, or maths is too difficult. I would think that's entirely not true. So I know there's dyscalculia and all these not all these, but dyscalculia is the main one. But this idea of I can't do maths is incredibly incorrect. So how I do this is you might need to be taught differently. And that's where I am going to motivate a lot of these videos. Because I know, and I've had teachers in the past who would just be like this. They'd be writing stuff on the board, and we're all down here on our desks, or sort of in front of our desks, taking stuff down sort of aimlessly. Now, of course, I'm going into a bit of psychology topics here, but this is called the chalk and talk method, which is really, really terrible. So oftentimes facts are kind of spewed out with no real justification as to how they work. But how I'm going to work these videos is whenever I'm explaining things, I will usually have a motivation as to why on earth we're learning this, as well as where everything comes from, otherwise known as its derivation. So as I'm writing, I'll give you ample clearance as to the main ideas of a concept, where the concept comes from, and an easy way to remember any sort of, if there was any order to the concept. So hopefully that this method, using YouTube videos, will help you be more confident in maths. I will take things very slowly. You can go back and review anything that you need. And if there's any other clarification people need, the comment section is freely open. So what we're going to do before we get into any Leaving Cert content is I will do a couple of sample Junior Cert questions that I'm going to be taking from the Complete Maths workbook, and then we'll get into some Leaving Cert maths.